Good evening, everyone. My name is Rohit Nikam. I am a student of SYCAC BTech, and my topic presentation is all about the subject discrete mathematics, and the topic is groups. So let us go inside in it. My groups is nothing but a monoid with an inverse element. So we can say in an order pair of set G comma star, the G is a non-empty set like or a group in an algebraic system, and the star is the binary operation on the G. This G is said to be an group when and only if it satisfies three conditions. These three conditions are nothing but the associative properties, identity property, and inverse property. So we can see first associative property. Associative property is nothing but three. If we have an three elements x, y, z, the addition of these three element with the help of with the differentiation in the parentheses should be equal. That is nothing but the associative property. Identity property, there an exit an element E which belongs to the group G. There should be an element E which is belong to the group G, and element another element which of a group G. We have a multiplication of this element. The final answer should be the element which we have taken at the start. So last property is inverse property, element. Inverse element is nothing but for every x there is a belongs to G, there is exits and a minus x. This nothing but when we multiplication of an plus x and minus x, we get an element which we took in this before property, that is E. There is an important note about this group, that is nothing but group is a special case of a semi group and monoids. So this is all about the groups, and next let us go for the next topics. So next is our topic is abelian group. It is also nothing but same order set of in G and star. In this G is a non-empty set of in group, and star is this binary operation on the G. So this abelian group is the special type of group which has all the five properties in it. They are closure property, associative property, identity property, inverse property, and commutative property. So before we have seen associative property, identity, and inverse. So let us first see about the closure property and commutative property more. First, closure property. For this, in this, all the elements x and y belongs to the A, such that x both the addition of these two elements should be the value which we have taken in the element A. Like if there is a set A, the addition of the elements by taking different elements should be present in the set A itself. Then it is satisfies the closure property. As a so the associative property, identity property, and the inverse property we have all seen in the groups. So let us move forward to this commutative property. In this, for all the elements of the, if we taking an element, that should be belongs to the set A, and the addition of the any two elements of the set A should be is equal also equal to the element present in the A. So it is known it then it satisfies this property. So let us, it is all about the abelian group. Let us move forward. There is our topic is all about order of group and the degree of group. Order of group and degree of group are nothing but the first we can see the order. Order of group is also represented in an order G comma star, that is G is a non-empty set and star is the binary operation on the G. It is denoted by the number of elements in the set. The number of elements in the set is said to be the order of an group, and the degree of group is nothing but the permutations are defined. In this, the number of elements present in the set which permutation is defined is known as degree of the group. That is, we have given a small example over here. S is equal to 1 comma 2 comma 3. The how many elements, number of elements in this set is 3, so the degree of group is also 3. uh, there is an important note in this about the degree of group is bijection mapping of n numbers are n factorial. This thing we have seen in the permutation concept. So at the last slide, I have given a small example where we are taking the set yes as 1, 2, 3, and for that the permutation possible are 6. But here we define the permutation as a set yes, and therefore the element present in the set yes are the degree of the group. So the degree of group will become 3. Thank you. This is all about the groups, permutation, abelian group, and degree of group. And thank you.